Hello everyone, it's Darwin with CSIWindows.com. Today I want to go through a template build with you. We're going to kind of imagine that we are accelerating a 1 or 2 year process as someone's learning how to use PowerShell, keeps building different scripts and starts to realize, it would really be helpful if some of this code was managed in a more templated way so that they can reuse it, so they can put that code in a structured and meaningful way. So we're going to take a look at some of the steps we might go through over time. We're going to start with the uber generic program Hello World, and of course PowerShell is capable of the shortest Hello World program in the world. And we're just going to save it here in a folder. We're going to call it, let's do a new folder and we'll call it PSH template. And we'll save our Hello World. I'll give it a run, see that it's working right. There we go. Hello World. Our program is working good enough. Now we're going to add something that is normally added around this time, or when people start to really realize, hey, every time I run this script, I don't want to have to go to the machine that has a problem, rerun it, and observe it real time as to what it's doing. In some cases, you may not even be able to do that because you're actually running the script in the background. So let's take a look at adding some basic logging. So we're going to create our first function here, and we're going to call it write_log. And within this function, I am actually going to, right off the get-go, I'm going to use proper param statements. It's harder to get, we have to move pretty quickly to proper param statements to do everything that we will eventually do. So in PowerShell, you can, like in VBScript, create parameters up here if you wanted to. However, there are some limitations. So we're going to create a param statement, and in a param block, we will then create an individual parameter. And we need a parameter to be passed in order to allow us to send the message. So whatever message we're going to log, so I'm going to do mandatory equals $true, and it's going to be a string, and we'll call it $msg. So that's our basic parameter that we'll receive into this function. And then to do our logging is quite simple. We're going to do add content, and we'll specify our file name. Now, to keep things simple up front here, we're just going to do environment public, which will give us the C users public profile folder on a standard Windows 7 build. And we're going to call the log by the same name as our script, Hello World. We'll give it the same capitalization even, .log. And then we have to give it the actual text that we want to write to that file. So we have our logging function. Now to see it actually work, I'll clean up our code a bit here. We're going to create a logging statement or two here. So first we will say write log attempting to say hello. And then we'll confirm that we were able to do that. Hello has been successfully said. Okay, so we'll give this a run. We can see we have Hello World here. Let's check out how our log file turned out. Use the same environment variable and Hello World. And here we can see that our lines have been logged. So we'll take that off the screen. So now we have some logging built in, very helpful when we're trying to determine why something has gone wrong when we're working with our scripting. So that capability is a pretty cool capability. Now, another thing that's really helpful in logging is the ability to have header information. So header information can tell us things about the system on which this log ran. So you may have logs shared with you from other support people or others that are using your scripts, And when they share those logs, they might say they pulled them off of a certain given machine that's having the problem. But it's very frequent that people make errors when pulling logs. So they pull the wrong log off the machine, or they pull a log off of the wrong machine. Right log, but wrong machine. So we're going to add some header information in here to make sure that when we get this log, it is what we think it is. So we're going to say start of a new log. You can decide whether to make your logs overwrite each other or accumulate. One of the benefits of accumulating the same log file over multiple runs is that it will show you the effect of multiple attempts to run a script. So in some cases, people keep trying to run the script again and again to get it to work, and you're able to tell that. So we're going to say computer name, because it would be nice to know which computer this comes off of. And I'm going to do $env for environment variable, computer name, and close quote. I'm also going to put this inside of dollar parentheses. That just makes sure that that evaluates correctly no matter what kind of delimiters we have before or after it. And we'll do another one. Another thing that's good to know is who the user is. So we'll do a username. Technically it's user ID. And we'll do the same thing here. Close all of our different delimiters. $env username. So that'll give us the user's ID, and then we're going to also want to log exactly which script created this log. And in order to do that, we're going to use a special object that is part of every PowerShell session that can tell us where the script executed from. It's going to be $myinvocation.mycommand.definition. So that'll be the full path to our PS1 file. And so we can tell, first of all, exactly which PS1 ran, but we can also tell where it ran from. Maybe you have a test location and you also push it through SCCM. Maybe when it goes through SCCM, it goes to distribution points or runs from distribution points or gets copied locally. Well, we can tell from this full path exactly which of those scenarios it was in. We're then going to do a delimiter, and just want to show you that you can do some interesting character operations here. So we can say star times 30. So that gives us 30 stars. It's a mathematical operation, so in order to turn it into a string, we put this guy around it, and then to make it a parameter to our right log, we put quotes around it again. So we have star times 30, and that's the character star in the quotes there. And then we resolve that operation with the dollars around the parens and turn it into a string. And so we can write that out to our log. So now let's give it a run and see if we get some additional logging data. Looks like it ran successfully, and we now get a log that has more data in it as to what has been done. So the next thing we're going to do is add the date to every time a log line is run. This is a very common thing to do. And in PowerShell, because we can run operations and drop them right into a string, we'll go ahead and do that here as well. It'll keep it simple. So we're going to do some type of operation here. Specifically, we're going to call the getDate commandlet, and we're going to give it a format command, and we're going to give it the G format, which is very similar to the JLogging format, and we'll put a colon here to indicate the rest of it is the message. All right, give it a run and take a look. And now we have time date stamps for each line in the log file. Time date stamps are very helpful when debugging things. We're able to compare it to other logs in the system, like the event log or other text logs. It also allows us to understand if something that we ran in our script took an extra long time that we weren't expecting. Maybe your script has trying to copy a file from the network, and in a given situation it fails. You notice that that copy was very slow, and maybe figure out they were running over VPN, so that explains it. So time date stamp is pretty critical and should always be included in your log file. The next step we're going to do is keep our main script, working script here, from becoming burdened with template functions. So these functions have to be placed at the top of the script before they are used. So as we add more and more functionality, we end up building up a higher and higher level of additional code here. So what we're going to do is create a new library, and I'm going to do a save as on it, and we will put it in a new location, and the location we're going to choose is going to be relative to our main script. So here's our main script. I'm going to include includes subfolder, and that will allow our script to always, whenever we copy the root of it anywhere, it will always have everything it needs to run, and will run from that root. I'm going to call it CSI core library.ps1. Later on, I'm going to explain a naming convention that we'll follow in order to allow us to dynamically load whatever libraries happen to be in this location. I'm now going to grab the code that comprises our template code that isn't part of our working code and save it. And then in here, we are going to create a way of referencing that code. First of all, we're going to create a way of referencing our current folder for this script. So we'll call that variable CSI script folder. And although you don't have to call your scripts all to have the CSI first part, you could create a kind of an abbreviation for your company or something else. It's important to pick one because then we can list all of the variables that are a part of our script very simply and easily by listing the variables that start with CSI underbar. And so that's why I'm going to be using that in the as we go through. So I'm going to use a special object called myInvocation, which happens to track information about our current running code within PowerShell. And so this will give us the full path to our script file. Of course, if we use it in a prompt that isn't a script file, it does not come back with anything. It only works in the context of an actual script file. Now, we don't want the actual full script file name, which is what this returns. Instead, we want it without the file name. So we use a special commandlet called split path, and we tell it we only want the parent. And the parent just means cut off the last level at the end and give me the result. So in this case, because there's a file name at the end, it finds that last slash, cuts that all off, and hands us back the path, which is the parent of the script, the full script file name. We are then going to use a dot operator, and the dot, it loads the code, tells PowerShell, load the code in this file right here at this location as if it had been always edited right into this location. And we're going to use quotes around the file name. Then we're going to use this same folder file name we have up here and paste it in there. And then we made that include subfolder, and we called our file CSI core library.ps1. So now this particular file will be loaded and run as if it was right in this location. So I'm going to press, actually I want to show you that I'm going to prove that it's actually reloading. If I do write log, it appears here, and if I press enter, it prompts me for parameters. If I, however, do a remove item function write log, I hit remote item there, sorry about that. Now if I do write log, I don't get it. It's prompting me to thinking, hey, you want write event log, because write log no longer exists. So when we run this, first of all, if it runs successfully, then that means it redefined that function. And if I type write log, then it appears. So we know that our include structure is now working. So next, what we want to do is enhance our logging function a little bit. We now have the ability to have it in the library. What I want to do is allow the log name and the log folder to be exposed in our script. We want the log folder in case we would like to put other things there. So let's say we run an MSI install and we'd like that log